Okay, it says that it's recording. We'll see. I've never done this before. So I guess we should get started. I think the agenda items for today, we're talking about the proposal for priority preemption, resource sharing between batch jobs, and then also talk about 1.7, other things. So Tim, you were the one who wanted to discuss it at this meeting, although I expected that we would have done it anyway. So do you want to start that discussion? Hopefully people have had a chance to read the proposal. It's kind of not trivial to summarize it. I guess the 10-second summary is that we're proposing to add priorities to pods, a preemption mechanism that allows pending pods to evict already running pods of a lower priority when the cluster is overcommitted, and also to introduce a batch job concept for gang scheduling of multiple resources needed for running batch jobs like Spark jobs, things like that. And a resource sharing mechanism that's not described in great detail, but is intended to be flexible enough to allow people to experiment with different resource arbitration strategies, including the kind that they have today in systems like Yarn and Mesos. So that's my 10-second explanation. So Tim, do you want to start talk about it?
Well, I think the first question is that, the document has an opinionated view of some of the batch mechanisms that you guys may have worked with, but I think there might be several implementations that it's not really clear as a non-goal from the beginning of the document that this is almost like an architectural perspective. Like, this is one way we could possibly solve this type of solution where the primary theme of the document is priority preemption, but the outline specifics of this particular batch implementation is one of what could be many.
Yeah, I mean, I think that relates to a comment that you and I think at least one other person, I think Joe Bita, made the same related comment about whether this should have been separated into two documents. And I think, I sent to the mailing list my opinion on this. I mean, I think it could have gone either way, and there's good arguments on both sides. Sort of in separating the priority preemption stuff from the batch scheduling and the resource arbitration among batch job stuff. My argument was that they should be considered together, although definitely there needs to be separate design docs in more detail for both of these things. That wasn't what this was trying to do. Like you said, this was just trying to do a high-level architecture, and that probably was not made clear enough in the document. But the argument for combining them was just that, we're talking about how to, how to share the resources in a cluster. That's too vague to be meaningful. But specifically, like how to decide which workloads and which parts of which workloads are most important at any given time, and who should be made to wait. And that kind of issue happens kind of in both systems, the batch queuing model, and then also in the priority preemption stuff. They're kind of both doing preemption of a sort and prioritizing stuff. And so that's why I kind of wanted people to be thinking about them together. And so that's why we combine. I mean, the Eric Toon and Enerud and the people in SIG apps have been thinking about this batch scheduling, this gang scheduling for batch stuff already because they needed something for Spark to set up multiple resources, both the ones that produce pods and the ones that produce other kinds of API resources like secrets and stuff like that. And so they had been thinking about some kind of batch queuing system and batch admission system. And then I had been thinking about the priority and preemption. I mean, there's been discussions going on for a long time. And then the third piece of the puzzle was Klaus from IBM, who had a proposal. I forgot what it's called. It was called like multiple applications sharing a Kubernetes cluster or something. And he had written up a proposal, and there had been some discussion on that. And so I thought this was a good time to try to pull together those three different threads into something that we could talk about as a unified proposal. But I do understand that it's a lot of moving pieces, and that it's useful to decompose them as we go into more detail. I mean, at this stage, I just kind of was curious what people think about kind of the overall architecture that was proposed there.
I feel like on one side it was nice for the authors to try to consider all the things, but for consumption of other people, maybe would have been better to have 2 or 3 separate docs.
Yeah, and I think we will have to have 2 or 3 separate docs. I'm not sure I agree that it's only useful for the authors to consider these issues together. I mean, I think that, we want the community to understand and evaluate whether this is a good idea, because, we do want to get consensus on this kind of thing. And I think that, this is, maybe we shouldn't waste time arguing about this. This is just philosophical. But like seeing how these 3 different pieces fit together, I think is beneficial. But other people have disagreed, and I can see that perspective too.
I don't think. I think it's just a matter of language in the beginning, honestly, so that what this document actually, the purpose and the intent behind it, to explicitly state that it's like a non-goal of this document to outline, like the actual batch system itself. This is an example of one. And, the implementation details could be left. It's what's the primary focus of is just priority preemption, but you're outlining these other pieces of the puzzle to give you an idea of how the model would work.
Yeah, I think
just having that text in the beginning would help to clarify the ambiguity.
Yeah, I think we were trying to do something a little bit stronger in the sense that, I think Eric phrased it well in the doc. I don't have it open at the moment, but there are certain fixed pieces that we're proposing that would make it possible for people to then experiment with the different batch strategies. Like, for example, the admission control quota, the quota admission control. And how that works for allocating resources between queues and sort of making queues the fundamental abstraction and stuff like that. I think that's the kind of thing that we would want to get some consensus on. There's a lot of stuff that I think we would want to be open for experimentation, and it should be possible for multiple people to implement different batch job controllers and experiment with policies and stuff like that. But and so that people can, because there's all kinds of allocation policies out there in the real world. But I think there are certain pieces, and maybe that's part of the process of processing this document is understanding which are the pieces we want to be kind of fixed and say this is part of the architecture, and which are the pieces that are just, like you said, here's an example, here's an illustration of this kind of thing you could do.
Yeah, I like that last summary. Your last sentence actually was concise and it would help a lot. The other point I wanted to make too as well, you've used gang scheduling a number of times, but I wanted to make sure it's used in the context that most other people understand it. Because gang scheduling is usually bulk block scheduling done in one single alloc or round, typically for purposes of MPI jobs, where you have a coordinated start and your resource starting is important. Did you specifically mean it that way, or were you referring to it in some other context?
Yeah, that's a good question. I think we've been abusing the term, and I think you're completely right that we shouldn't be doing it. We were we were talking about gang scheduling. One aspect of it being scheduling things like secrets and volumes at the same time as you admit a job that's going to be producing pods and things like that. And that may not be the right terminology, especially since I'm not sure how strong a guarantee we can give to being to the schedulability of the pod producing thing, since we don't have atomic scheduling, anything like that. So it's probably weaker than true gang scheduling, I think.
So, but there is a tie-in here. I think, in a sense, if you have true gang scheduling, you would need a way to say, I'm submitting this thing and I need 100 things that are this shape or 100 machines or whatever and I need them all at once. Mm-hmm. And we're saying you could instead submit a pod that then goes and schedules 100 things And so we want some way to like pre-reserve resources without requiring the exact shape of the thing that you want to run to be specified in a very verbose configuration language as part of Kubernetes. What if you need like 100 things like this and 20 to look like that and 47 look like that? Like, I don't want to write down a config file. I want to like have a fairly good probability that this now is the time to launch that, and then launch a program that then goes and launches the gangs that I need, the collections of identical things that I need.
Some people might call that some level of resource reservation. I don't know if Connor wants to chime in or not, but
there's a desire to like, so there's three things there. There's like a desire to have an aggregate resource specification for a deferred like collection creation,
yes.
Which says like, there should be this many resources before you even think about starting this. It still might not be enough if there's weird bin backing problems, but this is about what I'm going to need. Then you want a way to say, I'm going to make a bunch of things, and if you have to clean up all these things, label them the same. And then the third thing that's not addressed in that doc at all, but that we probably do want someday, is the ability to say, like, make all these pods, and then if any of them get terminated, like, delete them. And it's not clear whether that belongs in the scheduler or, like, in a controller level. And that last one is closest to what you're calling what the correct definition of gang scheduling is, I guess.
Yes, yes.
But they're kind of tied together. Like you're saying, if you have to kill this pod, then you might as well clean up the rest of me.
Yeah, I think we want to accommodate different kinds of jobs. The kind where I've heard a good term internally used at Google for I think crystalline or something like jobs where like if any one instance dies, and I mean there's multiple definitions of it, but one would be like if unless you can run all of the instances, you shouldn't bother to run any of them. But then there's others where like Spark with like I forgot what like where there's some mode in Spark where it can I think it's called dynamic allocation, where it can dynamically vary the number of tasks that are running, the number of executors over time, and so it can adapt to the fact that there may be less or more resources, and it wouldn't want to be killed if it gets less. So I mean, I definitely think that we would want to accommodate both kinds of jobs.
So even in the Spark case, there is a notion of the minimum number of resources you want to reserve a priori, and yeah, so the former use case is more common.
Yeah, so I mean that's a good point too. There's a hybrid, I guess, where it's like there's some, well, exactly what you said. But like if I can't get at least this much, then kill me. But ideally, I'd like more, and sort of within that range, it's okay to reduce my allocation as long as you don't go below some certain value.
Yeah, I think the terminology would be either call it reservations or resource hoarding. Resource hoarding is usually the example of like, give me as much as I can. If I can't allocate enough, then don't do it.
So I have a question for people that have worked heavily in other batch systems. Is there like one correct, well-accepted model for queues, or is this something where everyone's got an opinion about it and it's better to like make sure it's pluggable so everyone can do their own thing? Or are people going to, if we come up with something that's reasonably flexible, is everyone going to use it? So there's something we should copy like Yarn or SunGrid Engine, or should we just like, are there any thoughts on that?
There's so many.
Prior art, but what should I do with all that prior art?
Make it pluggable is the answer. Okay. Because the only thing you can do is make it pluggable, because some people will create their own priority mechanism and they will experiment with ideas. And I think that experimentation alone is worth its weight in gold, because what you'll probably find is people will create a novel implementation of some system, whether it be some stream processing engine or some other system, where they'll have their own weights and models based upon whatever problem they're trying to solve. And in other systems, what you'll find too is there's no canonical example, and sometimes it's more expressive than it is. It's massively wide open space, right? The system of batch processing goes back 30 years.
I would definitely say that in the Yarn universe, there are originally 3, now really 2 major schedulers, because it was originally decided to make it pluggable. And the fact that it was pluggable led to a bunch of innovation that the original Hadoop team at Yahoo and did not come up with. So the pluggability was valuable from a project perspective.
But now that that's happened, can we just take the best of it and call it a day, or do we still need pluggability, Sean?
I have to imagine that were somebody trying to make a system in Yarn that also had continuously long-running applications, the two existing ones wouldn't work well for them, and so they'd have to explore a whole bunch of new design space. So my suspicion is that the pluggability is pretty useful.
Well, I think I was thinking about it is the priority and preemption mechanisms would probably be not very pluggable. And the concept of having like a collection that gets enqueued, like in a queue to be run in the future, that would be pre-architected into Kubernetes. But the policies about who could use which queues, how queues cascade to each other, how you prioritize which queues to run, what resources are needed before you start something from a queue or preempt something from different queues, that would be highly pluggable. Does that make sense? And so only batch jobs would use queues, and only batch jobs would need a pluggable policy, whereas long-running jobs would just be started directly using resource quota. So there would need to be some pluggable interaction between like long-running resource quota, which basically is like, if you imagine a time dimension to quota, it's quota that is constant for over the entire timeline, versus like batch quota where you have an aggregate amount that you're then shuffling amongst different sub-uses. I don't know if that makes any sense, but that's how I was thinking about it.
Yeah, and we tried to capture that in the doc, I think, but maybe didn't do a good job. I think that was a really good explanation.
The problem with a lot of systems, too, is they want to rebalance dynamically. So even if you had a quoting system, you might want to have an expressive policy by which you can change the evaluation. And this was commonly done on existing legacy systems, including LSF and Condor, where it was much more expressive to be done on the fly. Right, so that way you could rebalance your whole cluster upon a couple of knobs.
Yeah, I'm sorry. Go ahead, Tim.
I'm wondering if there's some kind of approach where the primitive operations that are possible, like preempt this thing, launch this thing right now, right? Reserve this in a batchy way. If those operations are available operations and there's a kind of pluggable piece of code that maybe has a thread or two that runs in one active place at a moment, and that thing then uses those primitives so that you could, like, the decisions about what to preempt or whatever could be very pluggable, but the actual operations are in a framework way.
I agree.
I think the dividing line, I think, is the thing that requires some more thought. Like, what is part of the primitives that everybody uses, and what is the policy part? Because I think you can draw the line multiple ways. Yeah.
Does Yarn have that, and do you feel like it's an example to be followed?
Yarn has it. There's in Yarn, the actions themselves are even more primitive, right? The actions aren't even preempt this or whatever. The actions are like messages that you send to the nodes, and I think they went a little too far. They could have had slightly higher level operations that are a little safer to use. But the policies of, hey, preempt this, don't preempt this, launch this in a batchy way or whatever, it's not, you wouldn't use those words in Yarn, but those policies absolutely are pluggable. And they're pluggable once. You basically say, in Yarn, you say, here's your scheduler. And that, in one scheduler comes kit and caboodle, all of those things.
The way I've been thinking about it is like, when a pod is on a node, like the policy there is like that preemption, that's not pluggable. That's up to kubelet. You really can't affect that. When you are like have multiple things that are pending and you need to like schedule something now, that's not pluggable other than the fact that a scheduler is pluggable. But like if you're using a stock scheduler, you can't really plug in how priorities handle things for pods that are pending. Mm-hmm. But then for like a group of pods to be created in the future, meaning like a replication controller or deployment or whatever, like if you want to create that at a future time, and then it's going to make more things. Like that collection of entities is like, that's a queued job, and that is highly configurable how you preempt that collection.
I bet you could make something like that to work, right? The idea that you say, if Kubernetes, Kubernetes could have an API promise that if you set up your priorities this way, then Kubernetes will choose to preempt in this way. You like this ordering or whatever. And then the thing that causes that there's an intermediary in between the user and what Kubernetes knows about those things, and that's the pluggable thing. So the user may speak one language to this pluggable thing, and then that pluggable thing goes and says, oh, okay, Kubernetes, your priorities are this in this order. And so then, Kubernetes is free to operate within that constraint that's set up for it. That feels like it could work. It's very different than Yarn, but that feels okay.
Yeah, so I mean, we kind of propose, like, I think the way that would fit in with what we proposed in the doc is that you could have something like an admission controller, not a quota, this is unrelated to quota, but like an admission controller that maps properties of the pod, like maybe it's QoS or some new field or something, to internal priority, which is the thing that we would put on the pod. And then that priority would be used by the scheduler and possibly other components to decide who to preempt and to do the preemption. So like, if I understood what you were suggesting correctly, it's kind of like adding a level of indirection between what the user specifies and the total ordering on the priorities that the system enforces.
Mm-hmm.
Yeah, so that I don't think that was explicitly mentioned in the doc, but I think that's a good idea. I mean, the related thing that we mentioned in the doc was that the cluster administrator should be able to map the names to the total order. Like, the suggestion was like not to have integers as the priorities, but just to have kind of an abstract string, and then the cluster administrator could define the total order on those strings that defines the priority hierarchy. But maybe an alternative to that, or certainly you could also combine it, but I don't know if it's necessary, would be kind of what you suggested, where instead of doing the indirection through the names that the cluster administrator specifies, you do the indirection through some admission controller that then assigns integer priorities.
The kubelet would make independent decisions if the hierarchy is like configurable string based. That'd be gross to distribute that hierarchy to all the nodes.
Sorry, I didn't hear what you said, Eric.
If we had non-numerical priorities, which were user configurable, then we would have to distribute that knowledge to every node. So kubelets can make independent pod preemption decisions.
It could be a delayed evaluation. If it's an expression that gets evaluated upon the number actually coming in, then during its cycle, it could evaluate, because usually there's periodic evaluation expressions that occur in other systems. So even on the kubelet, so like there's killing values and circles that occur to reevaluate priority and preemption on the nodes. And if it's an expression, then that value would be reevaluated every single time.
I have to admit, I don't quite understand the idea here of the string with the global string namespace with the operator specified ordering of those.
It's the hate for ints.
It's a hate for ints. I see. So that could be a scheme that could work. I mean, but I would suggest that maybe that scheme, having an operator say, these are my orderings or whatever, is something that could be in the pluggable part of what we just imagined. And the actual, and so the operator's interface, if they're using that instantiation of the plugin, might be this string ordering. I have some concerns about that, but it is a plausible implementation. But then what the rest of Kubernetes sees underneath doesn't have to be those strings, right? That thing could be responsible for setting a currently correct global namespace that could be just lexicographic ordering or integers or whatever. And since that thing is running in the cluster frequently, it doesn't have the same address.
Yeah. I think that's pretty reasonable.
So I'm hearing like users aren't allowed to specify integers because those have the problem of like,
oh yeah,
of like the 10 go to 20 problem, but that like cluster components like the scheduler and the kubelet should use integers, and that the API server should be the thing that's responsible for mapping strings to integers, and somehow and so there's never a remapping problem. I don't know if I haven't figured that out.
As long as there's an atomic way to get the information from this pluggable scheduler-ish thing to any individual node, and that can be a atomic consistent operation, you're probably good.
I don't understand what you mean by atomic.
If you need to update, let's say the thing that's going to the nodes that makes it decide what to preempt. If there are 30 pods on the nodes with varying integers or whatever things they are, you don't want to update 4 of them but not the other 26. You want to update all 30 at once.
As long as each decision maker has a consistent view of the mapping and knows what version it's operating on, then you can have different decision makers, delegate decision makers, kind of advance at their own rates.
Correct. That's what I mean.
Yeah, but the kubelet needs to use one decision for everything it's comparing.
Yeah. But I would think at a higher level point, I think this idea of the operator specified ordering should ideally be relegated to this pluggable thing, and is thus not a part of the core Kubernetes thing. It may be a reference implementation or something, but that kind of thing is an area that I would expect a community to innovate on.
I see. So I'm interpreting that users could specify numeric values if they wanted that's exposed to them, but our reference implementation says, here's suggested ones, gold, silver, and platinum priority, but you're free to redefine them in a way that's pluggable or whatever.
Yeah,
Yes.
But let me give another example, right? Like in the Yarn world, right? People are using these hierarchical queues where they say, 60% of my cluster goes to this business unit and 40% goes to that business unit.
Yes.
And and then within each business unit, they may have priorities of themselves. And so you can't ask business unit A and business unit B, like an operator trying to compare all of A's and B's individual things. They don't know how to compare them. Only within the business unit you know how to compare. So this global ordering doesn't work.
Every single system I've ever worked on has reinvented this piece.
Mm-hmm.
Yep.
So that's a fine aspect for pluggability.
And actually, that ties back into why I was arguing that these issues need to be considered together, like why we can combine priority and preemption and the batch scheduling stuff together. It's exactly that kind of interaction.
They're related.
The general feature that people call it, the general thing that, what's your name again? Sean. The general feature that people call it is usually some hierarchical group quota feature.
Yep.
Yeah.
That.
Yeah. I guess the question is how do you thing that might be an innovation here is how you mix hierarchical group quota for long running jobs with a hierarchical group quota for batch computation, how that relates to priorities, how both those are distributed, how when you submit a job, you're expressing whether or not you're consuming batch or long running quota.
Yep.
Yeah.
A useful distinction when people think about stuff running Kubernetes, that it's consuming long-running quota, which is given to that group indefinitely because it has a known business need, versus batch quota, which is somewhat shared and sloshed around due to unpredictable future needs. And so therefore we want to separate those. That's my view. I don't know if people agree with that.
The document kind of made a proposal in that regard, kind of a way to have separate quota for the long running stuff. It's called, I guess, continuous running in the doc, and the batch stuff, which could then be dynamically reallocated based on fair shares, hierarchical queues, and stuff like that. And I mean, I think the one other piece of that was we were proposing that the batch controller would have some interface to the collections that it's managing, so it could kind of like the scale sub-resource, where it could adjust the size of the jobs that it's running to keep them within the kind of the quota or the resource allocation budget. So that was sort of the kind of preemption-like mechanism that was proposed for batch, was something where the batch controller would be aware of the shares that each of the jobs should be using and would tell them to scale to the appropriate amount, and then the continuous running stuff would use kind of a more direct preemption mechanism where the scheduler could preempt lower priority things, and you could somehow separate the quota for the long running stuff and the batch stuff.
So here's an interesting phenomenon that I don't think a lot of people have keyed onto with Kubernetes, in the fact that you can create your own batch system atop by the notion of pods and the shape of your pod, right? And like I've talked about this sporadically with some other folks, but typical batch systems take advantage of they try to prevent you from going through scheduling again. That's actually the purpose of high throughput, right? So if your goal is primarily throughput, if you have something that has the same dimensions or similar dimensions, you do what's called claim reuse. So like you start up things again on that same machine without you going through this whole round robin thing. And that individual scheduler can have its own priority and preemption model outside of this. So if you simplify the process and you take all of the nomenclature that you have around batch and you just take it out, and the idea is that you have a very simple priority preemption model, they can do their own schema internally and use Kubernetes itself as they've landed on there to adjust their weights and shares, right? I think simplifying the model that you've created allows for other people to experiment using the primitives that already exist inside of the system.
Timothy, are you saying that you want people to be able to to specify when they submit their batch job, I need 100 times 1 gig and 1 core pods, and then when they get to the front of the queue and launched, they're guaranteed those 100 pod allocations?
I think it's a race. I think let a greedy algorithm exist. They try to submit what they can, but they maintain their own queues, right? I'm not saying have a queue within the system. I'm saying having a queue within each individual subsystem. Offload the logic onto another system so they maintain their queue entirely. Why put the queue inside the core when the queue can...
Model. You're saying have frameworks and then allocate frameworks claim resources, and then frameworks arbitrate amongst their tenants.
Exactly. It's a similar model to how Mesos kind of works, but that way you simplify the logic in the core.
You don't get any consistency across frameworks, which I think people kind of like the Kubernetes is consistent across applications that run on it.
Well, a consistency across, you'd have consistency across your model at the core, but like if you wanted to do your own system, you could design that, right? So I think there's this slide bar of what belongs in core and what belongs outside. And I think for the first part, we could probably slide the slide bar down to prevent everything being the minimal set of priority preemption primitives into the core. And then over time, we can slide that out, right? Where if patterns become emergent, we say to ourselves, okay, let's implement queues in the core for doing this, then we can do that, right?
Yeah, I mean, I think I kind of agree with Eric's observation about the consistency thing. I mean, you're kind of proposing a 2-level allocation thing, and maybe one way to combine these ideas together is...
It's not really 2-level, but yeah,
I mean, if you're saying you have per framework schedulers, somebody is deciding how much resources that each framework should get, right? So that was what I was referring to as like the first level allocation would be how much resources the framework should get, and then the framework gets to decide among its jobs. Maybe I misunderstood what you were suggesting.
I'm proposing something similar to that idea, but it's still central in the core. I think what I'm trying to push back on ever so gently is the notion of pre-baking in too many concepts into the core, and to support pluggability and start with very simple atoms and then slowly grow that over time. But what the proposal embarks upon is several core things, and they're all kind of interwoven based upon some experience that you guys have, right?
Yeah, I mean, so just to that makes sense. Just to finish the thought that I was going with before was that, like, the idea was you would enqueue these batch objects, and they could then, I guess, manage. I guess I was going to say those controllers could then manage resources like within them, but it did have sort of a very one-level flavor, the thing that we proposed. And yeah, there's pros and cons of that.
I wonder if there's any Mesos users on the call, maybe that haven't talked yet, who could give a Mesos perspective, maybe talking about like marathon and batch happening in the same cluster, or how frameworks versus hierarchical group quota. Anyone that wants to chat about that?
I've got one point to add, just to kind of build on what Tim said before. I think that the most important concept to bring in would be to make the queue public. Kind of like you have in your design, where you have a first-class thing called a queue, and the pods that you need to run are inspectable easily from the API. Because one problem that happens when you're trying to gang schedule is eventually you see that you're starved and you're wondering why isn't my thing running? And if the queue is only in like the memory space of your framework, then it makes it super hard to debug.
Right, but since pods have a finite lifetime, that means we would have to introduce like a pod allocation concept and then gang schedule those like allocations, I guess.
Well, I'm not sure.
You can't just put a bunch of pod objects in a queue, because if one of the machines one's running on gets deleted, then you have to replace it with a new pod, I guess.
In this class.
Also, there is a slightly different type of batch job to consider. For example, the background job, say, for example, a compaction job, which is not really controller schedule, but more of node or application driven. I mean, one mode is to say that, hey, you trigger it explicitly only through control. The other common mode which is deployed today is, for example, Ceph or some storage node, is essentially the background job is triggered based, automatically triggered based on, available space, right? And the question is then we need to tie that into the overall scheduling to get the maximal benefits. I don't know whether this is addressed today. I'm very, very new to this proposal, just catching up. If not, I can write that up at least in a paragraph, what that means.
It sounds like a batch job that's very important to run on a timely basis.
No, what I meant was, yes, I mean, there are two modes of running it. One is, for example, the background compaction, on storage background compaction, you want to do it on time trigger. Other is automatic. And today the systems are deployed more in automatic fashion often. I mean, basically when you start seeing, hey, you're running out of space, you automatically run that batch job internally within that node, right? So the question is now, this has an overall scheduling impact. The question is, how is that being conveyed to the controller, right? Basically the master, so that it can make the right scheduling decisions. And this could last, I mean, basically, it could be few seconds. I mean, it could be or even longer. It depends on the type of job it is, but it's triggered automatically versus being scheduled by a controller.
Yeah, I'm not sure I understand the distinction. I mean, like I think the proposal here is that everything would go through some kind of controller, right? And it would be making the decision about if anything needs to be preempted or scaled down because the new work is higher priority. It wasn't clear to me if the thing you're describing does or doesn't fit into that model.
It's more like a use case. The question is, while we are considering, I mean, revamping the scheduler, considering all types of jobs, then how does this fit into that paradigm, right? Basically, it's a background job. It can be triggered through a controller, or it could be automatic. And today, systems are deployed more in an automated fashion. When there is a triggered threshold, hey, when you run out of space or some other trigger, then you basically start that background job automatically in the node. But none, if you're doing HA, then if you convey that information to the central scheduler, then the scheduler can do a better job of overall resource scheduling, right? So it's a slight variation of a batch job which I'm bringing in. The question is whether we want to start thinking about at this point here, or do you consider that, hey, is it a separate extension effort, or, you know, a various way to think about?
I mean, I would hope that we could come up with something that could accommodate that. I mean, like if it's something that needs to run right away, then you would run it at either in a high priority queue if it's a batch job, or at a high priority if it's it's not a continuous running job. So like it would be like if you considered a batch job, then I guess you would like run it in a high priority queue or something like that. I mean, we didn't have any concrete proposal like here about deadlines. We weren't trying to do anything like, you know, deadline based scheduling or time shifting. It was more like, you know, release the job once the necessary resources are available, but it's all kind of real time. It's not like reshuffling the ordering of pending jobs so that like the ones that are due soon run sooner. That's an extension that we were kind of not trying to bite off all of that at once. But like I think if you have some kind of compaction thing or something that needs to run now, then, you know, hopefully the priority mechanism would work for that.
Absolutely. Locally, it will certainly work, but my question is, in a HA model, if you're scheduling to multiple nodes, then, you know, is there something which, you know, can be done smarter with the scheduling, or overall just load balancing the traffic? Probably I would think dynamic load balancing of the traffic would be more applicable than scheduling, is what I'm seeing now, thinking about it more and more. Because I mean, depending on the time frame, I mean, basically how long it runs, then it may not be scheduling impactable. If it's going to run for a minute, then maybe the scheduler can, in that window, do a better job of scheduling other resources, right? But if the time window is probably, you know, seconds, then maybe it just comes to dynamic workload load balancing, right? It just depends on the type of job it is, I guess.
I think we might benefit from seeing your more specific use case and trying to get on that.
Yeah, feel free to send that out to the mailing list. Yeah, I was just going to say, feel free to send it out to the mailing lists that were invited to this meeting. That would be good.
Thank you.
Yeah, sure. Eric, were you saying something?
Yeah, Connor made a comment about the ability to inspect the things that are in the queue, and I think I kind of responded off the cuff to that, and I want to go back and understand it better, because do you want to say any more about the use case for inspecting the resource requirements of things in the queue?
Yeah, sure. So just 2 seconds of background for people unfamiliar with Mesos, but it's kind of backwards from Kubernetes, where you have a bunch of frameworks and they receive a resource offer, and then at that point they can decide whether they want to run a task or not. And so they're, you know, each framework's queue of release tasks, meaning I know I need to run this thing, but I haven't yet scheduled it, is, you know, it's the responsibility of each framework to maintain, and there's no API in the system for to get a global view of the union of all the release tasks for the connected frameworks. So I was just saying that if we have a you know, a batch job scheduler that has hidden release tasks, it's going to be difficult to get all the information you need to drive preemption, because you won't know if somebody's starved. So if it ends up in the API, then I think it's okay, and it can be totally pluggable. I agree with everything else that Tim said about, you know, just having small primitives. It totally makes sense. But
there are multiple. There are multiple scheduler models that are not the framework-based design that do have global priority sorting, but they do push. There's periodic evaluation where all the schedulers push to a collector what their queues are, or what their individual queues are, and then that's globally sorted, right? It's the problem with Mesos is because it's a different two-phase model, but it has the approach of you having the ability to have individual atomic units that can execute with their own local priority, but then get periodically resolved with global priority ordering.
Yeah, I mean, I think that I don't know that we've figured out we definitely haven't figured out all the details here, but I mean, I think the idea that how the queues would work that Eric and Andrew were thinking of was like, the work that a batch job wanted to do would go into this queue, and then it would have some kind of controller that was responsible for like managing the resource allocation for it and killing pods if it needs to scale down and stuff like that. And so, I mean, what you're talking about is kind of like how do you get the demand signal from the framework into the centralized scheduling framework. And I think kind of the idea was at a high level was that magic would happen in that batch scheduling, that batch job controller. And the demand signal would be coming from the Spark controller and the other frame, those kinds of things. But I don't know that we figured out we definitely didn't figure out the details of that.
I have a question about something that I saw in the doc, and I think I just heard. Why is it that we think that the scheduling of the long-running containers and the containers from the batch jobs or pods, whatever, why do we think that they're totally separate? And in particular, what I'm thinking about is if an organization, this case where an organization, a sub-organization wants some amount of resource here, and a different sub-organization wants some amount of resource there. With the high-level org may just want to say, you guys get so much, you guys get that much, and each organization might figure out how much they want to spend on long-running and how much they want to spend on batch, and they don't have to keep going back to the high level to reevaluate that balance. And I'm worried that if we start with the separation being batch versus long-running, and carve it up that way, it makes the model that I
my thing froze.
Yeah, you froze right at the end, Sean, and I was totally agreeing with you. I'm like nodding. And
I would say, if you want to separate the two, is it hard to do that model?
I think we were trying to kind of shoehorn this into shoehorn is kind of a pejorative, but like into the quota model that we have today in Kubernetes. And one way that you can do that is, you give quotas to namespaces, and then you can use your quota either for batch or long running. Right. And I think that I don't know that we want to tie it to namespace, but I think that the idea that you can use your quota flexibly is a good requirement to have. I think that the quota needs to be per priority level, just so you don't get an arms race where everyone figures out what maps to int max and sets their priority to that. But definitely being able to flexibly share the quota between the batch and serving stuff. At least at first thought, it seems like a reasonable requirement to have. And I'm not completely sure whether the proposal does that well or not. I forgot the details of it, but yeah.
So I guess two things you might be saying. I guess one would be you should be able to use the cluster's resources flexibly between long running and batch jobs. And the other thing you might say is should there be a difference between how I start something I expect to run basically forever versus something that I want to I know the duration or has a finite duration?
Well, I have to imagine that there's a difference between those last two cases, right? I somehow have to tell the cluster what kind it is.
Well, yeah, and I think that the ship has already sailed on that second thing. We have separate abstractions for replica set and stateful set and job and stuff like that. So I think it's kind of too late to say you don't distinguish those.
Yeah, but you have to be able to say just somehow that they are sharing things out of the same pool.
Yes, definitely.
With your quota.
One thing that I want to clarify, David, you said that the ship has sailed, but before, I'm not sure if we were considering those differences, basically whether a job finishes at some point or continues to run. Scheduling decisions. Basically, something that finishes at some point, of course, is done and releases its resources, and those resources will become available, so scheduler can schedule more jobs in its place. So by saying that you want to have a distinction between these when adding like priority and preemption, are we saying that the scheduler is going to decide, for example, let's say that you have a job with the same priority as a continuously running service, and the scheduler is going to make a distinction between the two when deciding which one to schedule first. So both of them have the same priority, and they are
Well,
up to different time.
I mean, I think the model that we were proposing was that the scheduler, like the default scheduler, is just real time, whatever is pending, like and doesn't fit. Whereas the batch job controller was more of like admitting jobs when there's enough free resources. So, I mean, they're kind of, and I think we probably need to refine this distinction better, but they're kind of doing somewhat similar things, although the scheduler was always going to be involved in scheduling both kinds of jobs. Like the default scheduler is the thing that's scheduling pods. I mean, you know, one way to think of it is that the batch job controller is admitting whole jobs at a time, and then the default scheduler is scheduling the individual pods. I don't know if that answers your question or not.
Yeah, sort of, but it's not completely clear yet. As you said, we need to discuss it further, and we need to hash out the details.
So we got 4 minutes left. Is there a way we can summarize people's feedback as like not able to make a decision, keep going in this direction, do something different? Is there anything, what can we draw as actionable from this discussion?
I think what serves there is a document, but I think what I'd like to take a step back for is to refine the requirements such that we can all agree upon a very primitive set of requirements. Because if we do that, if we say like there's either going to be some definition between service and job, and where we can define priority and preemption models across those, if we have a concrete finite set of like 5 to 10 requirements, those alone would help drive, you know, potential implementations. But I think what we have is we reversed it. We have a potential implementation, and we don't necessarily have the definitive set of requirements, because what will happen is I'm sure the IBM guys will go off and redefine what exactly they need, right? And, you know, folks from different companies will also do similar things.
Is that something you can put together, Timothy? I mean, I know you have a lot of experience in this area.
I can help with it, but I can't. I think I can help solicit the requirements, and I can help work on them.
Yeah, maybe Tim, maybe you and I can work on that together.
Okay, but I don't think it should be more than like 10 fundamental simple requirements, right?
I agree with you, Tim. I agree with you on like a few simple requirements so that we can develop on that. And so once those requirements, maybe I don't know, a one-pager document just basically itemizing these requirements, and then we can work on those items and basically build more documents on how priority and preemption should work, and at the next step, maybe how batch scheduling should work and what is batch at all.
Yeah, I think we should have some process that will converge within a reasonable amount of time. I think maybe jumping to an implementation and not it was the wrong thing. I mean, I tried to have some listing of requirements in the doc, but it probably wasn't complete enough. And I definitely take Tim's comment to heart that the distinction between what is fixed part of the architecture and what is drop-in replaceable was not clear and maybe even not completely thought out. So I think that in terms of stuff I took away from Tim's comments, that was the biggest thing for me, was that we need to refine that distinction in addition to the requirements part.
Sure. Yeah, and I'm happy to help if I can do anything to find these.
Definitely. But we should figure out a way to get this to converge relatively quickly, because I mean, there is, just so people understand the drivers of this, like Klaus and the IBM folks are very eager, as you probably saw from that GitHub issue, to get working on a batch sharing, resource sharing work. We have a P0 request from the node SIG to have a priority mechanism that they can use on the kubelet to drive eviction ordering. And then also we have, just in general, people have always been asking for a preemption mechanism for continuous running jobs, not just for batch jobs. that we want. So I think, there's been, like Tim alluded to, there's been decades of research in this area. I think we should try to not spend decades coming up with the design. We should figure out how we can get this to converge relatively quickly, at least the high level. I mean, like I said, that was my goal, was that we could figure out, what the high level architecture is, and then people could experiment with the more detailed lower levels and write separate docs. So yeah, I don't know. Maybe the next. We're kind of out of time, but I mean, I don't know if people want to talk about it again at the next meeting, or maybe Tim and I can talk about the requirements offline. And in the meantime, I can try to clarify the document in some of the axes that people brought up here. I don't know if people have other suggestions. Eric, did you have any suggestion?
No. I mean, no.
Perhaps maybe later this week we can set up like a interim meeting or something just to hash through some of the proposed requirements and come to it with just a couple of them in mind, and then we can, for a smaller subset of folks who are interested, we could just work on that bit.
Sure. We could also, try doing it by email or with a doc to start with, and then meet to kind of finalize the list would be one possibility, so that we can make it easier for more people to participate. Anyway, I'm getting kicked out of this room. I'm sorry. You guys can continue talking, but I gotta go.